Hi guys, this is a video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you are looking for elsewhere. There's a lot of information out there. Be aware that I'm not perfect, so there may be the occasional mistake. I apologize in advance for this. So today, we are going to be going over lesson 1.2, part 2, which covers common multiples and least common multiples. So we have a few vocab terms to go over. The first one being multiple. A multiple is the product of a whole number and any other whole number. So the product of a whole number and any whole number. Example of this would be 16. 16 is a multiple of 4. Why is 16 a multiple of 4, or how is it a multiple of 4? Because if I take the product of 4 and 4, I'm going to get 16. You can also think of this as counting numbers. If I count by 4s, I'm going to get to 16. So 16 is a multiple of 4. Our next vocabulary term, common multiple. And this is half of our focus on this lesson. A common multiple is a number that is a multiple of 2 or more whole numbers. A number that is a multiple of 2 or more whole numbers. Example, 16. Earlier we said 16 is a multiple of 4. Because 4 times 4 is 16, or if you count by 4s, you'll get to 16. 4, 8, 12, 16. Well, 16 is also a common multiple, would be a common multiple of 2 and 4. So 16 is a common multiple of 2 and 4, and there are many other things it's a multiple of. So again, if you count by 4s, you're going to get to 16. But if I'm also looking at 2s, and I'm looking at multiples of 2, 2, 4, 6, 8, 10, 12, 14, 16. 16 you're going to get to in both of your lists if you're counting by 4s and 2s. So that's why 16 would be a common multiple of both of these numbers. Our last term, which is the focus of the other part of this lesson, is least common multiple. Least common multiple is often referred to as LCM for short, and the least common multiple is simply the common multiple of 2 or more numbers that has the least value. In other words, it's going to be the smallest. So the common multiple of 2 or more numbers that has the least value. Now, how do you find common multiples? There are 2 methods you can use. The first being listing or counting. So for example, if I was listing 2s or counting by 2s, I would go 2, 4, 6, 8, and keep going. The second method to find common multiples would be prime factorization. Prime factorization. And for this lesson, I'm going to be using the ladder method to do that. So 2 methods, listing. The second method, prime factorization. And again, I'll be using ladder. Apologize, I didn't have that under the camera. Okay, our first practice problem, we're going to be finding the first 3 common multiples of 8 and 12. The first 3 common multiples of 8 and 12. Now, which method are we going to use? We are going to start by using the listing method. Why? Because our numbers are relatively easy to count by, and they are on the small side. So if your numbers are easy to count by and they're small, I would recommend doing the listing method. If you have much larger numbers and they're not easy to count by, I would recommend prime factorization. Otherwise, it could take you hours, what it really should only take you a few minutes. And if you don't want to spend hours, make sure you're choosing the appropriate method. Otherwise, you only have yourself to blame. Okay, so we're going to use the listing method. Our first step, we're going to write out our numbers that we're going to be finding the common multiples of 8 and 12. And we're going to start by listing a few for each. And we're going to go back and forth. So for 8, 8 times 1 is 8, 8 times 2 is 16, then 24. We're going to stop and do some for 12. 12 times 1 is 12, then 24, and then 36. Now we're going to stop and look at both, and we're going to see if we can find a common multiple, a multiple that both of them have in common. I see that they both have 24 in common. This is our first common multiple. It also happens to be the smallest, and remember the smallest is referred to as our LCM. So technically 24 is our first common multiple. It's also our LCM, if we wanted to find that. We're going to start writing our answer over here on the right side. So our first 3 common multiples, I'm going to abbreviate CMs for short, are, our first one was 24, and now we need to find 2 more. Why? Because we need to find the first 3 common multiples, just not the first one. And after we go through this and the next example, I'm going to show you a shortcut, meaning I could stop right there and finish and figure out my next 2 numbers almost immediately. Okay, so what do we do if we're going to do it the long way? We continue counting by 8s and 12s until we get the next 2 numbers in common. So 8 times 4 is going to be 32, then 40, and then 48. Let's go over to our 12s. 12 times 4 is 48, then 60, and then 72. All right, let's stop and see if we have numbers in common. We do. The 48. That's our second common multiple. So I'm going to add it to my answer. And now we just need our last one. Let's continue counting by 8s. So we've got 56, 64, and 72. I can automatically right now see that 72 is in common. That is our third and final common multiple, 72. So we wanted the first 3 common multiples of 8 and 12. The first 3 they have in common are 24, 48, and 72. That is going to be our answer. Now, if you wanted more common multiples, you would simply use this same process, or you could use a shortcut we're going to mention in a little bit. 2 things to keep in mind. The first, the smallest and first common multiple is always going to be your LCM. So whenever we actually attempt to find the least common multiple, you can use the same method, but just stop And that's how you find your LCM. It's going to be the smallest and first one you come to. One other thing I would like to point out, if you look at these numbers, you're going to notice we have 24, 48, and 72. 24 times 1 is 24, 24 times 2 is 48, and 24 times 3 is 72. So in other words, I want you to notice that these three numbers all count by 24s. So you'll notice that these count by 24s. That's going to help us come up with our shortcut in a bit. All right, our second practice problem. We're going to find the first three common multiples again of 3 and 9 this time. The numbers are relatively small, they're easy to count by, so we're going to choose to use the listing method again. So first step, we're going to write our numbers, 3 and 9, and we're going to count a few multiples at a time for each. So for 3's, 3 times 1 is 3, then 6, then 9. Let's go over to our 9's. 9 times 1 is 9, 9 times 2 is 18, and then 27. We stop and see if they have anything in common. They do. They both have 9 in common. So 9 is our first common multiple. It's also known as our least common multiple because it's the smallest one they have in common. Let's go over here and go ahead and start writing our answer. The first three common multiples are, we've got 9. Now I wonder if these counted by 24s, wonder if these are going to count by 9s. I guess we'll find out. So let's go back and keep going. So 3 times 4 is 12. We keep counting by 3s. We get 15 and then 18. Let's stop and do some more on 9s. Or, actually, no, we're going to go ahead and stop because we see one in common already. 18. So our second one is 18. We're going to add that to our answer. Oh, guess what? It looks like they are going to count by 9s. So 9, 18. I wonder if the third one's going to be 27. So instead of counting more 9s, let's go ahead and continue with our 3s and see if we get to 27. So the next multiple of 3 after 18 is 21, 24, and look, it's amazing, 27. That is our third and final common multiple. 27. So it looks like since the first one is 9, all you have to do to get the next couple is simply count by that number, meaning we wouldn't necessarily have to do all this extra listing right here. So we're going to go ahead and stop since we have our first 3 common multiples. So that's going to be our answer. Just want to note again that the first and smallest one is known as your least common multiple, because it's the smallest one both numbers have in common. And again, I want you to observe that these counted by 9s. And these counted again by 24. So it seems to be whatever the first number is, that's what you can count by for extra. And that actually is going to be our shortcut. So we're going to jot down a shortcut for later use. Love shortcuts. Makes our lives a lot easier. Cuts out a lot of work. So our shortcut is, once you find the first common multiple, once you find the first common multiple, and I'm going to abbreviate CM for short, count by that number for more. So count by that number for more of them. So let's say I wanted the first 5 common multiples. All I have to do is continue on this example, counting by 9s for the last 2. For this example, if I wanted the first 5 common multiples instead of 3, I just need to add 24 2 more times. Remember, we're not doubling the numbers. You're counting by here 24s. Add 24, add 24, add 24 again. Here we're adding 9, adding 9, adding 9. So that is our shortcut. Once you find your first common multiple, in other words, the least common multiple, count by that number for more of them. Okay. Our third practice problem. All we're going to do is find the least common multiple of 6 and 9. So not the first 3 common multiples, not the first 5. We're just finding the least, meaning the first one. Because those numbers are relatively small and easy to count by, we're going to use listing again. Our numbers are 6 and 9. Let's count the first few multiples of 6. 6, 12, 18. Let's do some for 9. 9, 18, 27. Stop and see if there are any in common. They both have 18 in common. That's the first one. And since I just want the LCM, or the smallest one, that's our answer. We get to stop and say the LCM, or least common multiple, is 18. Now, let's say you did want more than just the least common multiple, and you wanted the first 3, or first 5 perhaps. You could use that shortcut. So we're going to just make a note of that. If you wanted the next common multiple, you would count by 18s. And that would be it. So I could add 18 and then get 36 for my next one, for example. Okay, our next practice problem. We're going to find the first 5 common multiples, so I'm going to show you that shortcut, and we're going to identify our least common multiple of 6 and 12. We are going to use the listing method, but I'm also going to show you the other method. Why am I going to show you another method if the listing method is so darn easy? It's called example 5. I'm going to show you what's going to happen if you just learn one method. Not all methods are easy and efficient for all problems. You have to know how to do it other ways. Otherwise, some problems could take you hours and hours and hours, and we don't have time for that. Math should be fun, not horrible. Okay, so let's find our first 5 common multiples and least common multiples, 6 and 12. First, we're going to use a listing method. So write out your numbers, 6 and 12. Count by 6s, 6, 12, 18. Let's do some 12s. 12. Oh, wait, I already see one. We can stop. That's our first common multiple, also known as our LCM. So I'm going to go ahead and write that answer that question first. So we're doing that least common multiple is 12. But don't forget, we have 2 questions. We also want to find the first 5 common multiples. So let's write that answer. The first 5 common multiples are, well, the first one was 12. And the shortcut is, once you find your first common multiple, simply count by that number. So I'm going to add 12s. 24, 36, 48, and 60. 1, 2, 3, 4, 5. We had the first 5 common multiples. So we have answered both questions. We found the LCM and the first 5 common multiples of 6 and 12. Now let's see what that would look like on such an easy example using our other method, which is prime factorization. It has 4 steps. The first step being do prime factorization for all numbers. Again, do prime factorization for all numbers. How are we going to do prime factorization? Using the ladder method. Step 2. Once you have done prime factorization for all your numbers, you're going to list the prime numbers you see. Again, list the prime numbers you see. And you only have to list them once. Step 3 is the longest, so don't let it confuse you. Simply go through each ladder and see which one has the most. Again, see which one has the most, that's important, of each prime number. So go through each ladder and see which one has the most of each prime number that you saw earlier. And you're going to write down however many you saw in that ladder. So, and you will write down. It goes a lot faster than it's actually written out in words. Don't worry. So, and you will write down however many there were. Last step, multiply your numbers. Okay, so we're going to try this method on our super easy example. We're still going to do 6 and 12. Remember, we already know these answers. So hopefully we get these answers. Otherwise, we have messed up. Okay, first step, do the prime factorization for all your numbers. So we have 6 and we have 12. All right, first, 6. We ask, is it prime? No, it's not prime. So you start your ladder. Next, what's the smallest prime number? 2. Will 2 divide into this even number? Yes. How many times? 2 will go into 6 3 times. Is 3 prime? Yes. We stop. You're finished with that ladder. Let's move on with our lives. 12. Is 12 prime? No. Start your ladder. Next, what's the smallest prime number? 2. Will 2 go into 12, this nice even number? Absolutely. How many times? It will go in 6 times. Is 6 prime? No. So continue your ladder. What's the smallest prime number? 2. Will 2 divide evenly into 6? Yes. How many times will it divide into 6? 3 times. Is 3 prime? Yes. We get to stop. We have finished the first step. So far, not too much work. All right, third step. I know it looks like a lot, but it's actually pretty easy. Actually, sorry, we're on step 2. Let's not get carried away now. List the prime numbers we see just once. So what prime numbers do I see? I see lots of 2s, lots of 3s. So I see 2s and I see 3s. Okay, pretty simple. All right, now to step 3. we're going to go through each ladder and see which one had the most of each of these prime numbers. So this is why I listed out what I saw. I see 2's. So which ladder has the most 2's? Well, this one has 1 2. This one has 2 2's. It's the winner. So which one has the most 2's? This one. Now what do I do with that? Well, it says you will write down however many there were. How many were there? I see 2 2's. So I'm going to write down 2 2's. Be careful. We're not writing down all the prime numbers you see. You're finding the winner, which one has the most 2's. I see 2 of them, so write down 2 of them. Now I'll cross that out. Okay, now I saw 3's. Which one has the most 3's? Oh, it's a tie, so pick one. I choose you. How many does it have? It only has 1 3. So I'm going to write down 1 3. It doesn't matter which ladder you choose. It's a tie. They both have just 1 3. Okay, I didn't see any other prime numbers, so I go to my last step. The last step says multiply those. So 2 times 2 is 4. 4 times 3 is 12. So what does that mean? This is our LCM. The LCM is 12. Is that what I was supposed to get? Absolutely. So again, it took a little bit more. It's fairly simple, and I still got that answer. Next, I still need to find the first 5 common multiples. So let's write that answer. The first 5 common multiples are, well, the first one's 12. I'm going to use that shortcut that says once you know your first one, or the LCM, simply count by that number. So 12, 24, 36, 48, and 60. Okay, now, why did we do this complicated method for such an easy problem that I could have simply just done that? Well, that's our next example. Sure, we should have probably done listing, but not all your problems are going to be this easy. So our last problem. Find the least common multiple of 78, 90, and 140. I don't know about you, but I kind of forgot how to count by 78. Yeah, not doing it. That's a little too much. And while I might be able to count by 90s fairly easily, 140, maybe. No, it's just too much. So I'm going to walk you through using this method right here. And after we find our answer, I want you to think about what on earth would that have looked like if you had listed your numbers instead. Okay, so we're going to use prime factorization. First step says do prime factorization for all numbers. So we have 78, then we have 90, and we have 140. First, 78. Is 78 prime? No. Start your ladder. What's the smallest prime number? 2. Will 2 divide evenly into 78? Well, yes, it's even. How many times will it divide into 78? Half of 70 is 35. Half of 8 is 4. 35 plus 4 is 39. You could also do some long division off to the side to figure that out. Is 39 prime? No. Continue your ladder. What's the smallest prime number? 2. Will 2 go into 39? Absolutely not. So I go to 3. Will 3 divide evenly into 39? Yes. How many times? 13. 13, 26, 39. Next, is 13 prime? Yes. So stop. Go to 90. 90 is not prime, so we start our ladder and ask, what's the smallest prime number? 2. Will 2 go into 90? Yes, it's even. What's half of 90? 45. Again, if you did not know that, do some long division off to the side. Next, is 45 prime? No, it's not. So continue your ladder. Smallest prime number is 2. Will 2 divide into 45? No, it's odd. What's the next prime number? 3. Will 3 go into 45? Yes. How many times will 3 go into 45? 15. 15, 30, 45. Is 15 prime? No, it's not. So we continue. It's exciting. What's the smallest prime number? 2. Will 2 go into 15 evenly? No. Will 3 go into 15 evenly? Yes. How many times? 5, 3, 6, 9, 12, 15. 5 times. Is 5 prime? Yes. So we get to stop. Last number, 140. Is 140 prime? No, it's not. I can divide that by lots of things. Smallest prime number is 2. Will 2 go into even numbers? Always. Now, what's half of 140? We'll think, what's half of 14? That's 7. I have that 0, so 70. Is 70 prime? No. Continue. What's the smallest prime number? 2. Will 2 go into even numbers? Yes. 2 will go into 70 35 times. Is 35 prime? No. Continue your ladder. Smallest prime number is 2. Will 2 go into 35 evenly? No. So I go to 3. Will 3 go into 35 evenly? Let's see, 5, 6, 7, 8. 8 is not divisible by 3, so neither is 35. So I go to 5. Will 5 go into 35? Yes. Why did I skip 4? Because 4 is not prime. Do not divide by anything but prime numbers. 5 will go into 35 7 times. Is 7 prime? Yes, so stop. It's prime. That's our first step. Next step. What prime numbers do I see? I see lots of 2s. I see lots of 3s. I see lots of 5s. I see lots of 7s. One right there. I see lots of 13. One right there. So I see 2s, 3s, 5s, 7, and 13. So I'm going to list them just once. That's like my checklist. Why do I want a checklist? Because now I have to go through and see which one is the winner. Which one has the most 2s? Which one has the most 3s? Which one has the most 5s? Which one has the most 7s? Which one has the most 13s? And I'll write down however many the winner has. Okay, which one has the most 2s? Winner, it has 2 2s. Write them down. And I probably should not have written those so close. Together, so yeah, that's going to bother me. Let's fix that right. Okay, let's do that again. It has 2 2s. Okay, that's better. Done with those. Now, next one. Which one has the most 3s? 1 3, 2 3s, no 3s. Winner, how many does it have? It has 2 3s. So write down 2 3s. Next, which one has the most 5s? No 5s, 1 5, 1 5. It's a tie, so just choose one. I choose you. It's got 1 5. Doesn't matter which one you choose. It's going to have 1 5. All right, next, which one has the most 7s? No 7s, no 7, 1 7. So write down 1 7. And last, which one has the most 13s? No 13s, no 13s, 1 13. It's the winner. Again, it has 1 13. Write it down. Last step, multiply. And whatever answer we get is going to be our least common multiple, meaning if you counted by 78s and counted by 90s and counted by 140s, the answer we get down here is going to be what that number would have been. Okay, so first, 2 times 2 is 4. Four times 3 is 12. 12 times 3 is 36. 36 times 5 is, well, I don't know. Let's do some work. 36 times 5. 5 times 6 is 30. Write your 0, carry your 3. 5 times 3 is 15, plus 3 is 18. All right, 180. Okay, next. 180 times 7. Yeah, I don't know, so let's do that. 180 times 7. 7 times 0 is 0. 7 times 8 is 56. 7 times 1 is 7. Plus 5 is 12. I can add. Yes, 12. All right, so 1,260, and now the last, times 13. Definitely don't know that, so let's do some extra work. 1,260 times 13. Okay, 3 times 0 is 0. 3 times 6 is 18. 3 times 2 is 6, plus 1 is 7. 3 times 1 is 3. Next, cross out that 1. All right, because we're in the second column, I need to add a 0 placeholder. So my answers will start here. All right, 1 times 0 is 0. 1 times 6 is 6. 1 times 2 is 2. 1 times 1 is 1. Last step, add. 0 and 0 is 0. 8 and 0 is 8. 7 and 6 is 13. Add the 2, the 3, and the carried 1. You get 6. And, well, 1 is just 1. Look at that sucker. All right. 16,380. That is our LCM. So let's write our answer and be finished with this problem. So the LCM is 16,380. Okay, I want you to think about this. How long would it take you to count by 78s correctly with no mistakes, count by 90s correctly with no mistakes, and count by 140s with no mistakes, and get to 16,380? I tried once. I didn't make it halfway, and I gave up after a couple hours. It's just not acceptable to do methods like listing for problems like this. So that is why I gave you this method. It will help you for when you have to find the LCM of very large numbers and lots of them. Again, I hope this has helped you figure out how to find many common multiples as well as least common multiples. If it hasn't, there are many videos out there. I encourage you to go find one that will help you. Y'all have a great day.